So the definition of density is that it equals mass divided by volume. Mass is measured in grams, which we abbreviate with a G. And volume can be measured one of two ways. So volume can be measured, first of all, in milliliters if the object is a liquid. The second way we can measure volume is centimeters cubed if the object is a solid. If you're measuring a liquid, you would get a graduated cylinder, you would measure the volume, and it'd be in milliliters. If you have a solid object, you would have to measure it using a ruler, and you would measure it in centimeters cubed. So how that works is, say you have a rectangle. This is a terrible picture, sorry. Meep. So here's my lopsided rectangle. And this lopsided rectangle is a three-dimensional object. So here you have the length of this side. We'll call that y. The length of this side, we'll call that x. So you have your xy axis. And then because it's a three-dimensional object, it goes back in space. And we can call this dimension z. So we have the x, y, and z dimensions. Each side is going to be measured in centimeters. So for z you have centimeters, y you have centimeters, x you have centimeters. So you have centimeters times 1 times 2 times 3 equals centimeters cubed, because you're measuring 3 sides. So that's where the cube comes from. So another thing that's important is this relationship. 1 milliliter equals 1 centimeter cubed. So because it's a 1-to-1 ratio, the units are really interchangeable. So sometimes you'll see me write the units milliliters. Sometimes you'll see me write the units centimeters cubed. They're interchangeable. It really, truly doesn't matter. So I'm just going to abbreviate density equals mass divided by volume. Therefore, density equals grams, which is the mass, divided by centimeters cubed. These would be the units for density. Or, because centimeters cubed equals 1 milliliter, we can say that the units for density are grams divided by milliliters. And these are the same thing. So you're going to have to use these units when calculating density. So then our first problem, what is the density of an object with a mass of 5 grams? So here I have the mass, and a volume of 10 milliliters. So this is measured in the volume. So I'm going to solve for density. So density equals mass divided by volume. So all I'm going to do is plug in these numbers. So density equals mass, which is 5 grams, divided by 10 milliliters. So this is going to be 0.5, and the units carry over. The units are just as important as the number. So it's 0.5 grams per milliliter. You have to have units on your calculations, and I put a box around it so that I know that it's the answer. Second question, what is the density of a piece of metal with a mass of 10 grams and a volume measured at 3 centimeters by 4 centimeters by 3 centimeters? So this doesn't give me a final volume. I have to calculate it. So if you think back to that little box that I just drew, or that little rectangle, I'm sorry, you could think of this now as a piece of metal. I need to measure the x-axis, the y-axis, and the z-axis. So we can just say this is 3 centimeters, oopsies, cm. This is 3 centimeters, and the z-axis is going to be 4 centimeters. So what I need to do is I need to find that value. So in your calculator, you would take 3 times 4 times 3. So you multiply the numbers through, and you're going to get a total of 36. Well, the units on that are centimeters cubed because there's 3 of them, so cm cubed. So this is my volume. So volume equals 36 centimeters cubed. So now I have my mass, I have my volume, I can calculate density. So density equals mass, which is 10 grams, divided by 36 centimeters cubed. So when I calculate 10 divided by 36, I get 0.28, and the units for this, grams divided by centimeters cubed. Because the units don't go anywhere. These don't cancel out. Next problem. So those were two problems to calculate density. What if I don't want to calculate density? What if I'm looking for the mass of an object and I already have the density and I already have the volume? So what we can do is we can manipulate the equation. So density equals mass divided by volume. But in this question, it's asking me to calculate for mass. So I'm solving for this variable right here. So a lot of times people have a hard time manipulating equations to solve for variables, so let me show you how to do that. What I want to do is I want to get mass alone so I can solve for mass, just like density was alone and I was able to solve for density. So I'm just going to do some simple algebra. So right now I have mass divided by volume. So I'm going to multiply both sides by volume so that this goes away over here. When I do that, I have volume times density equals mass. Well, that was easy enough, just using a little bit of algebra. So now I can solve for mass. So calculate the mass of an object that has a volume of 15 centimeters cubed. So I have 15 centimeters cubed. And I'm going to multiply that by the density, 4 grams per centimeter cubed. So you notice the units make sense. Centimeters cubed is the unit for volume. Grams per centimeter cubed, or grams divided by centimeters cubed, is the unit for density. This is going to equal mass. So in my calculator, I would just take 15 times 4, and I'm going to get 60. So the mass of this object is 60 grams. As far as the units go within the equation, how did I know that it was grams? Well, first of all, I'm asking you for the mass, and you should automatically assume that for mass you're going to be measuring in grams. But for the units, you can also double check your work. Here, we can just put this over a phantom 1 to turn it into a fraction. So in the numerator, I have centimeters cubed right here. And in the denominator, I have centimeters cubed. So when I multiply the numbers, I'm not only multiplying the numbers, I'm multiplying the units as well. So because these centimeters cancel out, the only unit I have left is grams. There's nothing to cancel out the unit grams, therefore it carries over into my answer. Next question. Find the volume of an object that has a density of 2.3 grams per milliliter and a mass of 4 grams. So again, I'm going to start with my base equation, which is density equals mass divided by volume, but this time I want to solve for the denominator variable. Again, a lot of times people have a really hard time doing this, so I'm going to manipulate the equation so that it'll make it a little bit more easy to solve for volume. So I'm going to do the exact same thing I just did on the last step. So I'm going to multiply both sides by volume because I don't like having anything in the denominator. So these volumes cancel out over here. So I'm left with volume times density equals mass, but I haven't got volume alone yet. So then what I'm going to do is I'm going to divide both sides by density because I want to get volume alone. So then the densities cancel out numerator, denominator, and I'm left with the equation volume equals mass divided by density. This is the equation that I can use to solve for volume because I now have the volume variable alone. So volume equals mass divided by density. And then I'm just going to plug in my numbers. So mass is 4 grams and density is 2.3 grams per milliliter. Remember, the units go along with the numbers. So then you take in your calculator 4 divided by 2.3 and you should get the answer 1.7. So let's look at the units here. I have a grams in the numerator, so I have 4 grams in the numerator, and I have a grams in the denominator for the density. Because I have the same variable in the numerator and the denominator, they cancel out. So the only unit I'm left with in this equation is milliliters, So those are the units that carry over into my answer, which makes sense because I'm asked to find the volume.